taking some more examples from the miscellaneous exercise. This is question number 5, which says solve the equation. You need to understand the difference whether they are asking us to prove it or they are asking us to solve it. Here it is solving the equation. That means we have to calculate the value of the variable, which is x here. It is already mentioned a is a non-zero real number. Okay. So we are going to simplify this entire equation and see what is the possible value of x. For solving the equation, I have applied the property C1 as C1 plus C2 plus C3. As you all are aware, when we solve them, we try to convert all the elements of any row or column into 1, 1, 1. Because the moment we are able to do that, we can easily convert any two of them into 0, 0, and then it can be expanded and solved easily. Okay. So applying C1 as C1 plus C2 plus C3. So in x plus a, x will get added, then again x gets added. So we get 3x plus a. In the same way, this element will become x plus x plus a plus x, again 3x plus a, and same here. Second and third column will remain as it is. Then taking 3x plus a common. See students, keep in mind when you take common any expression, put a bracket over it. It is not a getting multiplied with a determinant. It is entire 3x plus a. So when we take this common, all the three elements of first column will become 1, 1, 1. Second and third column will remain as it is. Then I am trying to convert these two into 0 with the help of the first element. So the operation taken is R2 as R2 minus R1 and R3 as R3 minus R1. So from row 2, we will subtract the corresponding elements of row 1. So 1 minus 1 gives us 0. Then x plus a minus x gives us a. Then x minus x gives us 0. Then applying on R3, 1 minus 1 gives us 0. Then x minus x gives us 0. X plus a minus x gives us a. Okay, so done with the operations, application of operations. Now expanding it through the first column. So when we expand it through the first column, with the element 1, a certain number gets multiplied, which can be obtained by hiding the first row and the first column. So 1 is multiplying with this minor determinant, which gives us a into a square minus 0. So 1 into a square is a square only. So the leftover expression is a square into 3x plus a, which is equal to 0. So either the first factor will be 0 or the second. But in the question it is already given a is not equal to 0. So second part cannot be 0. That means 3x plus a is 0, which gives us x is equal to minus a over 3. That means if x becomes minus a over 3, the value of this determinant will be equal to 0. Then moving on to the 11th one, where we have to prove this determinant to be equal to this expression, and that is to be done using the properties. So you quickly have a look at the determinant and see which operation is going to make our calculation easy. When you look at the first and the third column, you will see element involved in first and third column are different. So if I apply the operation C1 as C1 plus C2 plus C3, okay, a correction here, not C2 we will add, only we will add C3 to C1. So because second column elements are perfect squares, so in column 1 we will be adding only elements of column 3. So C1 is getting added to corresponding element of C3. It becomes alpha plus beta plus gamma. This becomes beta plus gamma plus alpha. This becomes gamma plus alpha plus beta. So all the three they reduce to the same sum. Then second column as it is, and third also, it is only the first one which is changed. Then alpha plus beta plus gamma is taken common from the first column. So this reduces to 1, 1, 1. Again you can see second and third column as it is. Now because we are able to convert all the elements of first column into 1, 1, 1, any two of them can be reduced to 0. So I am converting the one in second row and the one in third row into 0 with the help of the one in the first row. So the operation applied are R2 as R2 minus R1 and row 3 as row 3 minus row 1. So after this application, the determinant reduces to the product of alpha plus beta plus gamma. Now apply the operations. First row elements as it is we'll apply the operation in the second and the third row. Okay, see 1 minus 1 gives us 0. Then here we get beta square minus alpha square. The last part of this, gamma plus alpha minus beta minus gamma. So gamma and gamma will get cancelled out. You will get alpha minus beta. Then moving on to row 3, 1 minus 1 gives us 0. The next element will be gamma square minus alpha square. Third element, alpha plus beta minus gamma. So beta and beta gets cancelled out. We get alpha minus gamma. Now second column elements we will simplify a bit so that we can see if something can be taken common. First row as it is. Now see beta square minus alpha square can be beta minus alpha and beta plus alpha. Here I can take minus common and write it as beta minus alpha. Then gamma square minus alpha square can be written as gamma minus alpha, gamma plus alpha. Even here you can take minus common and write it as gamma minus alpha. Now see carefully, you will be able to locate few expressions common in second and third row. Sorry. See, in the second row we can take beta minus alpha common. In the third row, gamma minus alpha can be taken common. So taking these terms common, one we have taken beta minus alpha, also gamma minus alpha. Now the determinant is, this is 0, beta plus alpha. Here I have minus 1. This is 0, gamma plus alpha. This is minus 1. So now we can go for expanding it through first column. So expand along C1. Given factors which we have already taken common. Okay, now expanding it, you can see 1 will multiply with, so I am not writing 1 now because 1 multiplied with the value of this minor will be that number only. So see, first beta plus alpha will multiply with minus 1. So minus beta minus alpha. Then minus, this will multiply with minus. So minus and minus becomes plus. Minus 1 into minus sign. So 1 into gamma plus alpha, which will be gamma plus alpha. You will find alpha and alpha gets cancelled out here. You quickly check, do we need the factors in this form only? Because I need alpha minus beta, so I'll take minus sign common from here. Okay, assuming minus is taken common, this will become alpha minus beta. Then gamma minus alpha is needed, we'll write it as it is. Now keep in mind, one negative sign is already taken common. When we come to the next part, it is gamma minus beta. Because I need beta minus gamma, so one of the negative sign can be taken, minus 1 can be taken common from here. So minus 1 and minus 1 will become plus 1. And this is beta minus gamma as required, the right hand side.